Hello and welcome to the video on efficiency by scienceworksheets.co.uk. We're going to look at the definition of efficiency, how efficiency is calculated, some practice questions on efficiency, how Sankey diagrams are used to represent efficiency. Thank you for watching. Please remember to subscribe to support the channel. There are two main calculations for efficiency. There is useful energy output divided by the total energy input multiplied by 100, and there is also useful power output divided by total power input multiplied by 100. The multiply by 100 is optional. If you want the efficiency to come out as a decimal, then you will not multiply by 100. If you want the efficiency to come out as a percentage, then you will need to multiply by 100. The motor of crane A is supplied with 20,000 joules of energy and does work on an object to increase its gravitational potential energy store from 1500 joules to 4000 joules. Calculate the efficiency of the crane. You may wish to pause the video at this point because the workings and the solution are on the next slide so that you can calculate the answer yourself. To calculate the efficiency of the crane, we first need to work out the energy output of the crane. So that will be 4000 joules minus 1500 joules gives 2500 joules. Then if we use the efficiency equation, the useful energy output is 2500 divided by the total energy input, which is 20,000 joules, times 100 is 12.5%. Always remember, efficiency cannot be more than 100%, so it should always be less than 100%. If your efficiency calculation is more than 100%, recheck the calculations, because there is probably a mistake with the numbers or the calculation. A Sankey diagram can be drawn to represent efficiency. These are scale diagrams, and you will need to be able to read and interpret these scale diagrams as well as be able to draw them. On a Sankey diagram, the input energy is on the left, so in this case the input energy is the chemical energy. The useful output energy will always point towards the right, and in this case it's the kinetic energy. The wasted output energy will be pointing down, and in this case this is thermal energy. You will need to work out the scaling. Now, if we look at the chemical energy from the top of the arrow to the bottom, there are 40 tiny boxes, or 4 large squares. Now that will represent a total of 4000 joules for 40 boxes. So one box will be 100 joules. Remember, one box is 100 joules. If we look at the kinetic energy, which is the useful output energy, the red arrow is pointing to the right. You will need to count across the width of the arrow. I have used a blue arrow here to show you where that starts and finishes. That will be 25 boxes, so in total that will be 2500 joules. Remembering that scaling is that one box is 100 joules. If we look at the thermal energy, where the red arrow is pointing directly downwards, again we will need to count across the width of the arrow. I have marked that using the blue arrows, and there are 15 boxes, so that is 1500 joules. On the Sankey diagrams that you will do, you will have to count the boxes and calculate the output energies, or possibly calculate the input energy. Thank you for watching. Please remember to subscribe to the channel so that we can produce more videos. If you need to practice worksheets, please visit scienceworksheets.co.uk, where there are a selection of worksheets and mark schemes available.